All right, I think we should be good to go. Welcome, everyone. My name is Julio Pachon. I am a postdoctoral, a postdoc over at the University of Sydney. I am also a member of the Secretariat of the Aroura Soul think tank. And today we have a really exciting start of a three-part series on the nexus to soil, or how soil is the nexus to the solutions of many global existential problems. And this is a collaboration between Safe Soil, part of the Isha Outreach, and the Aroura Soil Security think tank. We have a really great panel put together for you guys today, in which we will start talking about the Soil Security Framework and the capacity and condition with Wortining and from the University of Sydney, and then we will move on to work to Christine Magaju from ICRAF over in Kenya, who will be talking to us about soil data for farmer-driven land restoration in Africa. Then we will move on to Dr. Wirastuti Wijayanti over at the Universitas Gadjah Mada in Indonesia, and she will be presenting a case study of using the soil security framework there. And then finally, we will have Sandra Evangelista, another postdoc at the University of Sydney, telling us about a case study in Australia. Each one of these will go for about 7 to 10 minutes. Depending upon timing, we will be able to have maybe one question in between the different talks. If not, we will save the questions towards the end, where we do have a Q&A set for about the last 20 minutes and then some closing remarks. Without further ado, let me go ahead and present the first speaker. Wortining is Wortining is over at the University of Sydney. She's a postdoctoral researcher fellow in not only soil security, but also soil carbon. And her focus is on evaluation of soil capacity and condition to safeguard soil into the future. She integrates advanced data analytics, proximal sensing, and machine learning to improve the prediction of soil properties using large spectral databases. And she's applying those approaches with digital soil mapping to strengthen the assessment of soil capacity and condition as a foundation for soil security going into the future. So take it away, Wartini.
Thank you, Julio. I think you provide very good introductions of what I did. So I'm just gonna share my screen in a second. Let me just make sure. All right, can you see the screen? Can I just confirm you can see the screen?
Yes, we can.
Okay. All right, perfect. Thanks for the introductions, Julio. So again, my name is Wartini. I'm a postdoctoral research fellow at the University of Sydney. My focus on the job is on regards of the soil security as well as soil carbon. But today, the topic of my talk will be mainly focusing on the soil security assessment framework. So for this work, I also need to acknowledge, because it's not done by myself, there are also a couple of colleagues that work with us to develop this framework. So including Sandra, which is one of the speakers tonight. There's also David, Julio, Nicolas, Anil, and so on and so forth, some of the supporter for the work. So what do people usually think of when we mention the word soil? I think in general, people would think about it's a place where they obtain the food from. So usually when people think of the word soil, it has some associations with food. Would the soil be able to support the demand for increasing food productions when the populations increases. So soil has often been linked to food security. However, food security is not the only existential challenges that is being faced by humanity. There are several existential challenges that is faced by humanity, including energy security, human health, ecosystem and environment, water security, climate change, and so on. So what we are proposing here is that all of these existential challenges doesn't exist on its own. It can all be interrelated. And in particularly, those can be interrelated to soil security. Soil, as we know, has many different roles. It can, of course, be a system in which it provides us food. It is also able to store and regulate water. It has also the ability to store carbon to mitigate climate change. Soil has also the ability to cycle nutrients in order to promote the plant growth. It is also a habitat for many microbial diversity that exists within the earth. So as you can see over here, it has many different roles, not just food productions. So because of that, there has been many existing soil caring concepts. The first few concepts that has been introduced include soil fertility and soil quality. Those concepts are mainly related to basically the ability of soil to produce food. So this concept has been developed, I think, after Industrial Revolution, so baby booming era, so there is lots of populations increases. People need to ensure that they have enough food to support the populations. And after that, because of this green revolutions, you are able to generate high yield, but then what happens to the soil starts to degrading. And then they generate another concept that's called protection. So they try to protect the soil from further degradations in a sense. I think one of the most known concepts at the moment is the soil health, but soil health is also mainly related to productivity of the ability of soil to promote food productions, to support food productions. So what we are trying to achieve here is, because soil has many different roles, we are trying to promote a more holistic concept that is called soil security, looking at the ability of soil to support many different roles. So over here, I'm showing an example of what other existing concepts that exist out there and how it's really how it is in comparison to a soil security concept. So within soil security concept itself, we acknowledge that there is 5 different dimensions. First of all, I should mention that this soil security concept is being developed by Professor Alex McBratney within the University of Sydney back in 2014 or 2013. So within this concept, we acknowledge that there are 5 different dimensions. The first one is capacity, and then there is conditions. I'll go through the more details of the meaning of each dimensions in a bit. And there's also capital, connectivity, as well as codifications. And within this concept, we also acknowledge that soil has many different roles on top of food productions. So we acknowledge that it has ability to store carbon, for example, becomes a habitat for biodiversity. It also provides many services, including mitigations of climate change, resilience towards many different threats. And on the left-hand side here, we are trying to map how this concept is more a holistic and like an overarching concept covering all other soil caring concepts that are out there. For example, soil fertility, you can see over here, it's mainly related to Food productions mainly relate to functions, not so much on the services or threats. They are very, very limited coverage. So I'll go more in depth onto each of the dimension. The first dimension that I'll be focusing on is capacity. Capacity meant the inherent ability of soil to perform certain role. So you can think of it like the bottles shown on the right-hand side here. So if you were to go to supermarket and buy a bottle of water, it comes in many different forms and size. Similarly, you can think of soil in a similar manner. Basically, the soil comes in many different forms and size as well. So the ability of soil to perform certain role is also depends on the type of soil. So within the soil security, we developed another concept that's called pedogenon to be able to segregate or identify a unique, or I guess classify those type of soil. So pedogenon is basically, we are trying to identify a specific information so we can aggregate a specific, or group it in a similar forming factors. Group the soil in a similar forming factors. So I'm showing here a case study that we developed to develop a pedogenon in Australia. So this can be done because of the development in the digital soil mapping, the development of GIS, computing performance, high performance computing. So all of those data enable us to develop pedogenon maps. So from those digital map informations, we perform unsupervised classifications to be able to group soil in a similar forming conditions to be able to group the soils accordingly. So after we performed the unsupervised classifications, one of the colleagues was able to identify that there are 1,370 classes of pedogenons within Australia. And this can then be further grouped into genosoil and phenosoil. What do I mean by that? Genosoil mainly refers to land or soil that has minimal human modifications. Meanwhile, phenosoil is soil in which there are more human interventions, mainly related to agriculture, for example. So the genosoil is limited human modification. So in this case, I'm showing like a forestry area on the right-hand image here. So using the same concept, there's another colleague that worked on this global pedogenon maps, Nicholas Frankos. So he was able to using the same concept, he was able to identify approximately 6,500 classes. If you're interested on this study, the paper is published. You can check the paper out for more details on how we arrive at this global pedogenon map. So back to soil capacity. How do we use this pedogenon map to identify soil capacity? So to identify soil capacity, we use the pedogenon map and we interrelated that with the land use data that we have collected. So I've told you before that we need to be able to segregate the genosoils and phenosoils. So for that, we are using the land use data. Basically, any land use that has minimal human interventions, which is the purple area over here, and the white area, as well as the dark green area of a production native forest, is considered as genosoil, and the remaining land uses are considered as phenosoil. So if we were to transform the map on the right-hand side, we will have something like that, in which most of the areas within Australia are genosoil, and there are the wheat belt area on the New South Wales on this end here are with the yellow color are considered as phenosoil because there are more human interventions on that area. So that's capacity. Capacity is usually being assessed on the genosoil. Meanwhile, condition is mainly being assessed on the phenosoil. So if you are thinking of the same bottles that I showed you before, capacity means what can the soil do? So it depends on the shape of the bottle. Conditions refers to how much water is in the bottle. So let's say if even though your capacity is high, if your water level is low, that means your condition is relatively low. On the other hand, if your bottle is like you can fit 1 liter and your cup or your condition is at 900 ml, so your condition is relatively good. So that's how you use this concept to gauge how well your soil is on performing certain role. So another dimension that I'm going to touch on, or briefly at least, is the capital. Capital refers to economical value of the soil. So if we were to turn this information into monetary value, what would that be? Another dimensions would be connectivity. Basically, it is, sorry, before I go back, I'll touch on this one. So on the capital, we tend to value things that are has a high value. So that's why we put this dimensions in there as well, because if soil has more value, then we tend to care more for it. So over here, connectivity meant basically the perceptions of relevancy of soil within people's life. If you ask the questions like what bonds do you have with the soil, what bonds does this people have with the soil, people tend to care more or value more about soil if they have a stronger connectivity. So hence we use this as one of the dimensions to be measured as well. And last but not least would be a codifications dimension. So codification refers to a policy or regulations to protect soil. So is there any regulations or laws that exist to protect soil out there? So if there's regulations, then people tend to, I guess, care more or be cautious more on how to protect soil. So how do we use all of these informations, and how are we able to determine whether or not the soil is secure? To do that, we developed something that's called a soil security assessment framework. Within this framework, we acknowledge that there are 4 different steps. The first one is the assessment target. Basically, you need to identify, because the soil has many different roles and many different dimensions that you can assess it with. The first step is to identify what exactly do you want to assess, because if you have to do the assessment across all the dimensions and all the roles, it will probably take some time. The next step is identify an indicator to be used to analyze or to assess the role that you're interested in. The following step will be converting all those informations into a utility of 0 to 1. This is quite important, especially if you are using many different soil properties in your indicators. The following step will be aggregate all these informations, so you get a average utility scores at the end to be able to assess what you're trying to measure. So if we were to go back to the first couple of slides that I have, so the first step will be basically identify if you want, for example, in Sandra's talk later on, she is going to be assessing capacity and conditions of soil to support nutrient cycling. And that will be me. Thank you very much.
Thank you, Artini, and that is a really, really strong start to set us up on the rest of the talks, because information alone is not going to save us to deal with all of those existential challenges that you've pointed out. It's going to be through connection and cooperation, and it seems like this provides a wider language in order to be able to cooperate. But let's hold any questions from this one to the end, and let's just jump right into the next speaker, who Christine Magaju. She is over at C4ECRAF, as already mentioned, and she has 7 years of experience working with soil and land health research, doing everything from monitoring and stakeholder engagement to increase ecosystem resilience. She has experience leading farmers centered around restoration activities, collection of large data across very large regions, doing data analysis and monitoring. She has so with all of that experience, I'm really looking forward to seeing what she can tell us about her work. Take it away, Christine.
Okay, Julio, let me know if you can see my screen.
I can, but I think that
All right,
I think we're seeing the background,
I know the presentation. All right,
not the
I'll stop
presentation.
sharing and I'll share it again.
Okay.
Great. And now?
It's starting. Let's give it a second.
Okay.
It's not quite showing up for me.
All right. This is, okay, I'm gonna try one more time.
Okay, now we can see it and
No, I
you can
can't.
next.
Awesome. Great. I'm just gonna make it full screen. All right. Thank you
Oh,
everybody, and thank you, Julio. Oh, you can
is
also,
it possible to
also,
swap displays?
Yeah.
On the
Yes.
Yeah.
Done.
Okay, now we got
Wonderful.
it.
Great. Oh, yeah, there's always the technical hitches, despite practicing. All right, thank you again. And as mentioned by Julio, my name is Christine Magaji. I work with C4ECRAF, and I help our team make sure beyond the data that we're collecting, beyond the evidence that we're developing, that it is accessible and useful for farmers, for other stakeholders at different scales. So it's a great pleasure to be able to talk about soil data for farmer-driven restoration. And I'm also representing my two colleagues, Dr. Lee Winowiki and Dr. Tor Vagen, who couldn't make the meeting today. Right. Just building up on what Ini presented, like healthy soil is the foundation for everything we do, right? It's not just about food security, it's about everything. So ecosystems thrive when soils are healthy. We thrive when soils are healthy. So it's something that it encompasses everything we do. So anything we do, any conversation we do when it comes to restoration and functioning, we need to start from soils. But having said that, though, we're losing billions of tons of fertile soils every year, globally, right? We're losing 24 billion tons of fertile soils every year. And in Africa, for example, like over 65% of the agricultural land is degraded. In Kenya, just to bring it closer to home, we lose about 24 tons per hectare of soil through erosion every year. So things are dire. So we cannot continue with the way we do things, that the business as usual is not an option. We need to target investments in soil health, but beyond that, we need to monitor them. We need to track. We need to make sure that they are prioritized and tracked. And to do that, we need data, right? Farmers, for those that have worked with farmers, for those that are farmers on the call, farmers know when their soils are not healthy, right? It can be from productivity, from their own local knowledge. They do know when their soils are not healthy, but they need more data. They need to know how exactly are their soils sick, to use that synonym, and how do they treat them? How do they remedy that? But beyond farmers, we actually need data to be able to guide action when it comes to restoration, both from the soil, but also ecosystem restoration, to inform approaches and interventions, but also to track changes over time. When we're investing in restoration activities, are we able to see how that's changing at the farmer level? Is soil organic matter increasing in the soil? Is erosion slowing down? Are yields improving? But also just to follow up on that, to understand the impact of the agricultural practices and some of the new management practices that we're bringing into the landscape, their impact on soil. But also like beyond that is to understand the variability and the complexity, both across farms, but also at landscapes. And the map on the right, it shows like a bit of that. It's a variation of soil organic carbon in terms of grams per kilogram of soil across a transect in Kenya. So all the way from like the western part of Kenya through the central, eastern, and you can see the north, the western, which is a lot more wetter, as higher carbon. So the lighter the color, the lower the carbon content as well. So we need to be able to have data to be able to show that gradient, but also to tailor recommendations and interventions. So why are we not doing that, right? Like there are challenges in the current ways that we assess both soil, but also land health in general. So in terms of methodologies that are inconsistent or not monitoring consistent indicators, there's data gaps, we're not sharing data when we collect it, but also we don't have enough monitoring protocols that are robust, but also that are easy and practical enough that land managers can do. And I'll talk a little bit for the next couple of slides about one of those protocols that we've been using both at for aircraft in Kenya and in over 40 countries across the global tropics. And that is the Land Degradation Surveillance Framework, the LDSF for short. So it's a comprehensive methodology for assessing soil and land health across multiple landscape, and it measures multiple indicators at the same georeference scale, allowing us then to be able to do robust assessments and measurements. And on the right, and some of the indicators of soil health measured include soil organic carbon, total nitrogen, as well as biological activity. So earthworms and the AMFs was, I'm not gonna try and say that info. And on the right, the picture on the right just shows some of the tools that you need to be able to conduct the assessment. So the protocol uses hierarchical sampling design with each site having 16. So each site is about like traditionally about 100 square kilometers and has about 16 clusters. And then each cluster has 10 plots and we collect data both at the plot level and the subplot level. So this allows for robust statistical analysis to assess what I talked about, the variability across multiple scales. So what can we do with this data? What are some of the insights we can get from this data as an example? So data from multiple locations. So from the 160 plots that I talked about, 10 plots in each 16 clusters, is used to develop predictive maps of various indicators. So combining field data, machine learning, and satellite and remote sensing, then we're able to develop predictive maps at scales that are relevant to different stakeholders, and in this case, including to farm level. So allowing us then to track interventions at the farm level. And this is an example from one of the restoration sites in Kenya, where we looked at the impact of on-farm restoration and soil and water conservation options on, for example, soil erosion. And for the map, so the darker the color, the lower the erosion, and areas that are a lot more browner have higher erosion. But also just to highlight the importance of assessing multiple indicators. So this is a map of soil organic carbon at the same with the same scale, with the same restoration sites. And you can see, so the lighter the color, the areas that are yellow indicates areas of low soil organic carbon content in terms of grams per kilograms, while darker ones indicate high levels. But also being able to combine link biophysical indicators, for example, understanding the effect of increasing tree cover on farm to soil organic carbon. But beyond that, it's about engaging farmers. It's both for monitoring and as I mentioned, in being able to use the data for their various management. So, and beyond collecting data, engaging with communities to understand the use cases for that. And then finally, in closing, just to summarize, I think soil data is important, but for me, it is, if they're going to drive the restoration, they need to be part of the process, right? We cannot have restoration where farmers are just participants, but they need to be key stakeholders with equal rights, with a great stake on the well-being of the soils and the ecosystem. But also, these informations need to be accessible and useful for both farmers and for different stakeholders. And I know I'm like a minute over, but just to mention what Ini also mentioned, like we need to talk about soil literacy. We need to make sure we're increasing that. So linking that to how people relate to soil and increasing their understanding and their care of soil health. Yeah, and that's it. Thanks, Willie. I hope I was able to cover in 8 minutes.
No, that's incredible. This is some work that I've been following for a long time, and it's really an impressive amount of work that you guys have put together in eCRAP with all your colleagues over there to secure spectral libraries and try to get a lot of these variability, and it very much connects with what Wartini was talking about. Perhaps we're not using the same exact jargon, but the ideas connect there because we're all working towards trying to understand how the variability is out there, how are people using it, and anything else. 65% degradation is very stark. Is quite a bit. But it also points out quite an opportunity for restoration and working together for that. What gives you optimism that we can actually restore the full 65 or part of that 65% that has been degraded, and how can perhaps some of the other dimensions that were discussed by Wartini, like codification, which would be about laws or anything like that, how do you see that working its way in there using all of this data that has been collected and working with people?
That's a great question. I think part of what gives me optimism is a codification of it. Like across Africa, there's really growing momentum to shift from just focusing on fertilizer use and just soils for food production to more soil health. So and part of that is I think attributed to like the Nairobi Declaration. So Kenya hosted the Africa Food and Fertilizer and Soil Health Summit in 2024, 2023, but that resulted in an action plan that sort of gives a framework, a roadmap for looking at soils from a soil health perspective, and not so much there, not just focusing on fertilizer. And just to bring something close to home, Kenya recently also launched its own soil management policy that sort of looks at provides a policy framework for soil and restoration management in the country. So I think aspects of that, so the focus, the momentum on soil health across the continent, but also the at the national level, at the policy level, but also even at the ground level, farmers are more aware of looking at soil health holistically, not just for food production, but also being able to show linkages between soil health and various aspects. So I think there is a lot of momentum in Kenya and across the continent when it comes to like soil health. So I think that gives me hope and actually, yeah, that we're on the right track in terms of moving away from that narrow focus of soil as a means of production to more holistic assessments and view and understanding of them.
Oh, that's really good. That's really good to hear. And we'll hold off any questions for the last 20 minutes. And going to the a little bit on another side of the world. Let's go to a case in Indonesia now with Dr. Wirastuti Wijayanti. Again, she is a professor there at the Laboratory of Remote Sensing in the Department of Geographic Information Science in the Faculty of Geography. She is an environmental geographer and academic whose work focuses mainly on spatial analysis, environmental monitoring, and sustainable development. She holds a doctorate from the University of New South Wales in Australia, and a bachelor's from the Universitas Gadjah Mada, where she works now. She is also the head of the Strategic Management Bureau and lecturer as well. She has all sorts of international collaborations, research, and that does well beyond just doing the research there locally, but connecting to other researchers around the world. So I'm really excited to talk to you. We're all talking to you, Dr. Wijayanti. Take it away.
Thank you so much, Zulio. Very good afternoon, everyone. It's my privilege to be able to to deliver the research that we have been done in Indonesia, especially in terms of soil security. As everyone know that the imbalance between rising demands and declining food availability pose a major challenge to global food system, not only in the international level, but also in Indonesia. Especially in Indonesia, Indonesia have very different characteristics compared to Australia, of course. And Indonesia as an archipelago country and with over 70,000 islands, create immense complexity in soil property and also degradation pattern. And with the soil degradation threat, agriculture productivity is heavily dependent on the soil health. And yet global soil degradation caused by erosion and chemical damage and poor land management is undermining both food security and ecosystem service. So our research today try to translate about the soil security that been delivered very well by Martini and also by Christine. And we try to develop a method how to establish assessment method across its 5 dimensions. And because we realized that the data, the spatial data that we have in Indonesia is not as comprehensive as Australia. So at the moment, we are only able to do the translating the soil security concept into 3 dimensions, which is the capability, condition, and capital. So, okay. So this research aims to identify the existing approaches related to the land capability assessment from agricultural food commodities that already exist in Indonesia. And we really hope from this existing algorithm of research, we are able to develop a method to quantify the soil capability and condition and also capital under the concept of soil security. And actually, we already tried to translate the concept of soil security from connectivity and also the codification dimension, but there is a challenge that we have to face regarding to the data complexity and also the data availability. So now at the moment, we will focus on that 3 dimension. And we hope that by choosing Central Java in Indonesia, we able to at least have a preview about how we move forward from this 3 dimension of the soil security to connectivity and to the codification. Why we choose Java Island? Because Java Islands play a really critical role in Indonesian food security due its highly productive soils, contributing over half of the nation rice output, and so the Java alone accounting about 18 and 32% of the rice production to supply the demand in Indonesia. However, because the island also bear the weight of being most dense populated, it's about 15 million in Central Java itself of the population. And also because the demand of the intensified land use pressure and also the soil degradation agricultural zone, we try to focus how the ability, the data that exists in Java is able to be utilized to identify the 3 dimensions for districts. And we conclude that effective soil management is really essential to cope that the problem. And we also identify that soil security from the 5 dimensions is the right approach to overcome the problem of the challenge in the Central Java. So, yep. This is the translating the soil security. Basically, we also try to identify the existing research and how to translate the soil security concept into the spatial modeling. Why spatial modeling? Because as I mentioned earlier, Indonesia is very vast archipelago country, and it's hard for us to do a really detailed and intense fieldwork collecting the soil data that really comprehensive and really represent the soil development process. So remote sensing and GIS is one approach that we utilize to identify what is actually the most approachable method, the robust method that we can use to identify the data that missing. And we try to put that together in the algorithm. And we already identify that into the factor and the soil capability and condition. And we use the scoring method that already introduced by Yang et al. 2018, but we use the two algorithms that already identified in Indonesia in terms of soil capability and soil condition. From this, we use the remote sensing data to translate or to derive the spatial data of the soil. We use the digital soil map from FAO, and also we use the legacy data from Indonesian Ministry of Agriculture for data scale 1 to 250,000. And so we also use the land use map, and also we try to identify the climate factor, which is in Indonesia, the climate the climate data actually produced in 1960s, and we try to translate or try to upscaling that using the CRIPS data to be able to get the more detailed data of the precipitation for Central Java. And we also involve the data, digital elevation model, and also the vegetation index to identify the density of the vegetation that exists in Central Java. So this is the list factor that we try to put together from the algorithm of the soil capability and also soil condition. And we identify and we elaborate the factor for the capability for erosion, drainage, and also the salinity and solidity. For condition, we put the soil organic matter and the total nitrogen, pH, and also bulk density. So this is all the data with various detail. We try to harmonize from the small scale to the medium scale, and for the very detailed scale to the medium scale to be able to deliver 250,000 scale data to be able to put together the information of the condition of and also the capital of the soil. And we also able to deliver the categorization of the soil security through the soil condition and also the soil capital. From here, we got the result that the soil security index in Central Java is quite high, but there is some challenge or there is a difference in the rice field area and also the dry field. Most of the rice field area is located the area near the mountain and have high precipitation. But the other side on the dry field, because the low precipitation and also the parent material matters, the productivity of the rice field or the like other vegetation that related to the horticulture or the plantation have a low index of soil security. So from here, we try to put together on there, and we are able to identify the soil security classes from the unsecure to the moderate to high secure and highly secure. And the total, the most of the area that high secure is 2,357, but most of the area are classified as a moderate to highly secure. We concerned about the moderate to the marginal secure level of the soil security. And this is the thing that we already promote to the local government, that we have to consider this area by the applying the high technology or the high agriculture mechanism to be able to increase the yield of the soil, and also to provide the education to the farmer and also the local government to increase the productivity of the soil. And we try to put that as soil security index into the productivity, and we identify that most of the high secure soil score is have a strong correlation with the high productivity, and the unsecure one, well, we don't have quite enough data. And in here, actually, this is very important to collect the data, whether the unsecure or the low soil security index is really related with the productivity in the real condition. So for this research, we are concerned that the accuracy and also the comprehensive data is really important. And soil security index using spatial data analysis is really significant, prominent to capture the soil variability and also to support scalable monitoring. And GIS remote sensing allow efficient and large-scale soil assessment and ideal for regional and national application. And we also want to promote the soil security concept to the government, especially the Ministry of Agriculture, to be able to inform that this is a good concept before we deliver, or before we decide the regulation and also the policy to be able to decrease or to eliminate the degradation of the soil, especially the area that really that has a really high the land use change, especially from the rice field or all the commodities field to the built up area. The recommendation is the integrated soil dimension, like we already discussed that. For the 5 dimension, I think we really need to put that in the holistic analysis, especially involving the social aspect that involve the community or the farmer or all the stakeholder that deal with the policy in the land management. And also the complete soil security assessment require connectivity and codification, and also social factor here need to be applied nationally, nationwide, so it can be feasible with the improved soil data resolution. I think that's all from me. Thank you so much, Julia, and also all the participants. We are looking forward to the question. Thank you.
Thank you so much for that very comprehensive analysis for that region of Indonesia, and it's very powerful to be able to have the spatial look and be able to show it to the government officials and be like, look right here, this is where it's moderately secure, and this is why, like, we have this framework that we can more easily. You also talked about some of the challenges in the very beginning of this. So which of the current, or which of these dimensions, or which of the different functions do you think is the hardest to capture in the case of Indonesia?
Well, thank you, Julio, for the really good question. I think most of 5 dimension actually is really challenge Indonesia, but the connectivity and also the codification is 2 dimension that we try to put that together, especially how to connect between stakeholder and connect between a physical or biophysical property of the soil, and also the social aspect of the soil in terms of the stakeholder. For the codification, I think in Indonesia, there are many perfect regulation and also policy, but how to translate the regulation, also policy language to the local community and also the local government, that is the key of the gap in Indonesia. So if we want to promote the connectivity, I think we really need to work hard to translate the soil security and also all the elements under the soil security, as mentioned by Wartini about the soil health, so and also how to inform the community about conserve the soil around them. In Indonesia at the moment, because the issues of climate change and also the carbon, we more focus on the vegetation. We only focus on the blue carbon. We focus on this water. We focus on the all the above ground element like biophysical above ground, but a lack of consideration of the soil itself. In fact, that the soil carbon, the soil conservation in terms of the soil health and also soil security is really important because it's the life of all the need of the human, especially about the food security and all the aspects that need to be supported to make the food security happen in Indonesia.
Thank you. Well, and by the way, I do encourage people to, on the chat, put any of the questions that we can discuss later at the very end. So if you have any questions for Wartini, for Christine, or for Wirastuti, please do make them on the chat, and we will get back to them. But let's move on to a case study in Australia. And Dr. Sandra Evangelista, she is a recent graduate of the University of Sydney. She is working as a postdoctoral research fellow in soil security and also soil carbon. Oh, sorry. Oh my goodness. Yeah. Her research focus is on quantitative frameworks to quantify soil security, and she is collaborating very closely with researchers in India to develop an AI-based monitoring platform for soil carbon sequestration. So really excited to have you on as well. Tell us a little bit about soil security in Australia. You are muted, but your screen has been shared.
Thank you, Julio. Thank you for the warm introduction. Hi, everyone. I'm very excited to share some work that we've been doing at the University of Sydney, looking at more of the quantitative side of soil security. And I'm very thankful for this opportunity. Okay, so today I'll be presenting a case study on how we can actually use the soil security assessment framework to estimate two dimensions, capacity and condition, which we heard earlier from Dr. Wotininang, and I'm looking at how we can use this assessment to assess one of the soil functions, which is soil nutrient cycling. And so this soil security assessment framework has various phases, which Watini mentioned earlier. This includes a point assessment target, indicator selection, utility estimation, also reference source selection, and the aggregation of the assessment. Unfortunately, we do not have time to go through all of this today, but I will try to touch on each of them in my case study and try to highlight what is unique about the framework. So firstly, we must identify what is the target that we want to assess. Which of the 5 dimensions, as well as which of the subcategory of function, service, or threat, and to what depth. For my case study in Australia, I was looking at the capacity for nutrient cycling in the topsoil. Once we identify the target, then we can select appropriate indicators that are specific to the function, service, or threat, as well as the dimension. Here, for my case study, I looked at and considered different aspects of nutrient cycling, which was supply, storage, and transformation of nutrients. And then from there, we can then transform the raw properties of these indicators into their utility. So this, as Rotini mentioned, is a unitless score from 0 to 1. And we do this by using utility graphs. And utility graphs reflect the relationship between the indicator and the function, which helps us to interpret the performance of the indicator to the function. And what is unique about this is that for different functions, services, or threats, you would have different indicators, or if you have the same indicators, you may have different utility graphs. What is probably the most unique about the soil security assessment framework is the use of reference soil. And we usually use the ideas of the petagenon concept, which are soils that have been developed under similar forming factors. If you remember from Watini's talk at the beginning, each petagenon has 2 states: the genosoil, which are soils that have been least disturbed, and the phenosoil, which has been modified by human impact. For my case study, which was in Australia, in the state of New South Wales, it's an area called the Hunter Valley. It is the oldest wine growing region in Australia, and it's famous for its Semillon wine. So for this region, I looked at the 5 dominant petagenon classes, and for each petagenon class, I sampled both the genosoil and the phenosoil. And finally, we aggregate the utility scores of the indicators. So jumping into the results, looking at the capacity of soil to cycle nutrients, we can immediately see that each petagenome differed in their capacity to cycle nutrients. And this already highlights the idea of petadiversity. Different soils are capable of different functions, levels of functions, service, and threats. And this is knowing the capacity is important for management, because when we know what the soil is capable of, we don't want to extend beyond that, because we might overexploit the soil, which can lead to soil degradation. But this is also important for restoration. What are we restoring it to? Could restoring the soil possibly change it more and to a state that we lose the petadiversity? Looking at condition, which we see as soil health, two different ways to estimate the difference. We basically see the difference between the phenosoil and the genosoil. Today I'll be looking at the relative difference, which is a division, but this difference indicates whether there is a change in the phenosoil to its respective genosoil. Has the soil changed? Has it improved, or has it degraded? So by looking at the nutrient cycling score of the genosoil and the phenosoil, we can immediately see that the phenosoil has deviated from the genosoil. And looking at the relative difference, we can see that some petagenomes have degraded, where others have improved in their ability to cycle nutrients. In this map, I have mapped the average of each petagenome class, the score of the condition score, and we can see the different areas that have degraded or improved. Similar to the previous talk, these spatial maps help us to identify which areas we need to prioritize. And by looking at some of these areas also have improved, which was a little bit surprising. We think that this might have been because the area had been managed for many, many years on improving yield and quality of wine. And we think that the increase in ability to, or increase in the condition to cycle nutrients could have been reflective of biomass production, because often nutrient cycling and biomass or productivity go hand in hand. But this also highlights that petagenomes or soil that have been managed very similarly can respond differently to land uses. So the main takeaways is that knowing soil capacity, which is often also could be known as soil quality, this inherent ability of soil helps us to interpret or give us a baseline to interpret soil condition, which we see as soil health. And soil security recognizes this petadiversity by recognizing capacity. Knowing capacity, we can manage the soil in a way that we avoid overexploiting it. And we see that soils can be more resilient than others to different land uses. But also, soils may naturally be in low capacity for a certain function, but that doesn't mean that they're unhealthy. That was, yeah. And soil security recognizes multifunctionality. I want to reiterate that with the soil security assessment framework, it's a matrix of assessments of a number of functions, services, as well as threats. Today, I only looked at one function. Often, soil health or condition assessments mainly focus on biomass production, but soil is more than about productivity. We believe that soil has its own purpose in the ecosystem. And today I only looked at two dimensions, which was capacity and condition. However, securing soil goes beyond the physical condition. To secure soil into the future, we need these other socio-economic and political dimensions. And this framework can help us to identify which function, service, or threat, or which dimension do we need to improve to secure soil in the long run? And thank you everyone for your attention.
Thank you, Sandra. That was great. Very. This idea of the diversity of soils is something that has been touched in all of the different talks, and it's been touched in different ways, such as the diversity in carbon, to the need to go around and collect data in different clusters in order to create a baseline. In your case, there's a classification done by clustering the pathogenesis of soils, like the different versions, whereas some other might be doing it by other properties. But that also means that if you're comparing it, if you're creating this denomination of pathogenon, and you're having to have a genosoil, does that mean that does every single one have a genosoil? Is there such a thing as a threatened or an endangered or a rare soil out there that needs special protection?
That's a great question. Initially, and at some point, all petagenons would have a genosoil. However, in different areas, due to how we've managed the soil, urbanization, genosoil, there are phenosoils that have lost their genosoil. And that's a threat to pedodiversity. We are losing these soil that have more into their natural state. And there was a recent publication by one of our colleagues who looked at the petagenons and found that a lot of phenosoils have lost their genosoil, and that's a scary thing, because these soil that have been unique and provided some service, essential service to an area, are now lost. They're extinct, and that's scary. And there is also this idea about when we change the soil so much, that the soil can be a new genosoil. And this idea is based off something in biology. I'm sorry, I can't remember the exact details, but where the DNA may move or deviate so much from the original that it becomes a different species. And so there's the same idea with the petagenon concept, where if you manage the soil so differently, the phenosoil so differently, that it may become a different genosoil. But yeah, thank you for your question.
Yeah, very interesting. Thank you so much, Sandra, as well as to all the other speakers. I think that it's fascinating the amount of work that is occurring around the world in order to better understand soils, to better connect people to soils, and with the revolution that has been occurring the last few years, in our ability to analyze that data is going to be quite interesting. Let's move ahead on to the panel. And I don't quite see any questions in the chat at the moment. But I am getting a notification that we will ask participants for any feedback, and we will put a link on the chat. So please be on the lookout and give us some feedback on this. We do have 2 more series that will touch upon the other dimensions we didn't touch on today, which are the next series will be on connectivity and capital, and then the last one will be on codification. With that said, you can already see the link for providing any feedback, and we'll open up the panel for any questions you may have. While you write those questions, let me go ahead with one of them, and Christine, the clustering, we've talked about these two different ways of creating a measurement. One of them being going out right now and creating a baseline of sorts. Because even if it's a very similar soil, if it gets managed exactly the same, the soil being different can have different results to it. What do you think of this pataginon? Is that something that could be developed there, or how have you guys been able to account for that difference in your work in eCraft, and how you communicate that to the different stakeholders you work with?
I'm gonna try and answer that, but I think so with it just so the thing that's constant is like the indicators that we're monitoring and how we're monitoring them. But in terms of like differences in in the soils, then you don't explain away the variability, right? You try and understand what is driving the variability, and that's what you communicate to farmers. So it's not necessarily the management. It can be, ecological conditions, how the soils were formed, like is it volcanic soils, is it alluvial soils, right? Like they will vary depending on various factors. Just being able to acknowledge the variability and explaining the variability, but also being able then going a next step and communicating how then based on the soil, like the different soil types, how does that react and respond to different management practices, and using the data then to be able to see, okay, is there linkages between how different soil types respond to or react to different management activities or like ecological practices. That will be my answer for now. So it's not so much, I think it's just being able to explain why the variability is occurring and then linking it to different factors.
Okay, yeah, that makes sense. Yeah, some of it can be explained like, well, the soil happens to be a little sandier, or it has more of the fine particles, or like Virastuti was saying, maybe it's because of the different parent material that created that soil. So that's a very good way to explain it.
As long as you're collecting it in the same way and to the same depth, then you're sort of, you can actually start explaining that, or reach out to Sandra to like get more in-depth information on the why and Martini.
And it seems like we have a question from Rico, and this question might be any of you can answer it. How does the research about social security framework approach the pillar of connectivity? Is it mainly about assessing it, or do you also look at the most effective ways to engage the public and build a broader appreciation for soil health? So, yeah, any of you can take it away. I'll ask Cortini. What do you think, Cortini?
I think you are better suited to answer the question, but I can give it a go. So for us, the soil security assessment framework basically assess how well connected are these people to a particular role that you're assessing. Julio did a recent publications on this. So the way he assessed it is by conducting like a short survey, like online survey to basically identify how well connected are these landowners or land managers are on addressing certain roles or certain functions or certain threats. For example, like how well do they know that they need to do some management, for example. And then the next question, is it mainly about, at this moment, it's about assessing it, and then you can identify gaps as well. So I think it has been mentioned in Dr. Virastuti's and Sandra's example. So by identifying gaps where basically you see a low capacity or conditions, in this case, you'll assess if you have low connectivity, and you can find a way on how to improve the connectivity to prevent further degradations, for example. Maybe you want to add something, Julio?
Yeah, and that's what I was hired to do here in the University of Sydney, to try to develop those tools on trying to understand how engaged people are, because people who are engaged with their soils and understand their soils lobby for their soils. I mean, farmers and the people that are the landholders, they're the first ones to understand that when there's erosion, when there's landslides, when there's all of these different things, it impacts them directly. The one thing that I will mention is that, so yes, this one was a little bit more of a survey, but I think in the long run, the idea is that any research that we create gets communicated a lot easier. So it's more of a less of a survey in which we capture just the information, but it does get into Rico's point that rather than being engaging about appreciation, is more about having a two-way conversation about soils. And we can do this very simply with us, all of us here today. I want you guys to think of a soil that you guys know. And it could be a place that you hiked. It could be a place that you know is where your water comes from because it's part of the watershed that goes into a dam, or that it feeds your aquifer, or where you get your food from. So try to think of that soil and what do you know about that? And that's kind of how we develop that idea out here with our colleagues. I don't see another question in the chat. I do see one. Yeah, I do see one. Can soil security framework be applied in a soil data in a soil data scarce environment like sub-Saharan Africa? I may direct this question to you, Christine. You've pointed out to quite a bit of new data. Would you consider sub-Saharan Africa to still be data scarce in this type of information, or have we achieved enough to be able to compile the information across the different dimensions?
I think there is enough data for some of the soil, like the soil framework dimensions, the soil security, particularly on the condition of soils. So I feel that there is a lot of data on indicators that feed into the soil, like the condition bit of the framework. But there's still room for more data collection, but there is also still room for collecting data across the other elements of the framework. I think the biggest challenge with the data at the moment is how the data has been collected, and that sort of goes back to what I was talking about earlier in terms of challenges. So data is not collected in a similar way for it to be able to make linkages across landscape, across countries, right? So you find like you have like patchwork of soil data that's collected, and so we're pushing for like more consistent data collection using like systematic data collection using similar tools, but also like just on indicators. But also like I think in Africa, there's a push for like soil information systems that the sort of that can be an entry point for the soil security framework in Africa. So I think it's not a direct answer to a yes, but it's not a no either. So I think there's a lot that's there. It's just creating the linkages, but also trying to sort of, I guess, link what exists to some of the conditions, but like having one data set that looks across all the elements. I've not come across it, but hopefully maybe someone else has. Thanks, Julio.
Yeah, no, thank you. That's a great response, and I do think that a lot of this data collection has happened somewhat recently, on the sense that that's part of the reason also that the data harmonization sometimes is very difficult. It was a big push, and it was yeah. I think that you explained it very well, how you guys were able to create this methodology to collect it across such vast region. But yeah, nonetheless, even with such concerted efforts, there was quite a bit of the data harmonization that needs to be done. Perhaps not only because of the organization of people, but just because soils are so different, you need different methods. to be able to collect that information. And then it becomes difficult to say, to compare, since you necessarily have to do different methods. So that's definitely part of it. With Astuti, in your results, we could see that we have that you were able to, that you've been thinking about the social security across all the different dimensions. Is there a way, like you communicated to the government and you were able to show these maps? What was the feedback like? So Christine was telling us about some of the efforts that are occurring in legislation there in Africa and Kenya. Can you tell us a little bit more of did you see any communication back from the government with the use of this, or outside of the research that you have had? Like, what is that happening in Indonesia at the moment on that?
Well, thank you, Julio. Yes, when we try to applying the social security framework as an instrumental to refilling the analytical gap, the government have a very positive feedback on that. Really have a positive response on that. But again, because the resources of the all dimension for the soil collection, and also because the accessibility of the area of most of Indonesia is not easy to be collected. And also when we try to inform that to the local government, when we do the assessment, for example, for the physical erosion risk, we cannot identify how the landholder or the local government respond to, and how the level of knowledge that already owned or owned by the local government or the landholder or the farmer. So I think the gap in there is again, like I mentioned before, it is important that the understanding the social security is need to be promoted, and how soil to be understood and governed and also valued socially is really important in Indonesia. So I think in terms of the connectivity and also codification, the evaluation of the soil policy and also soil implementation in Indonesia have to move forward, especially in put it together in the policy and also land use planning context. And also we have many policy in terms of legal protection, land tenure, and also the soil-related regulation. But again, in local level, I think there are many political aspects that we need to anticipate to be able to ensure that understanding of the soil itself is really understood by all the stakeholders. At the moment, our Indonesian government promote more about the soil health, and they try to integrate it border with the environmental governance. I think this is a good move from the government to try to promote the soil health itself, but they more focus more on the environmental health in terms of the One Health. So it's the connectivity is more in how the soil and the environmental impact the animal and also the human health, instead of how to remediate or how to restore the soil quality and soil health itself. So I think that's the big homework that we have to do in Indonesia, especially because the economic in Indonesia at the moment is really in the lowest situation, and they focus more on how to increase the productivity of the commodity in terms of agriculture. So we have been intensively informed to the government that you have to focus on the area that have a really high land degradation, for example, for the mining use land, or the pit land, is that they already have a lot of land use change in the pit land, but because of the pit land have its own character, so when they try to drain it, the pit land, they're not able to cultivate all the commodity that they expected. as you know that there are like 1 million of the peatland have been converted into the plantation, but then after that, because it failed, they just leave it like that without any significant restoration in such a big area. So I think promoting about the restoration of the soil, remediation of the soil in part of the connectivity, and also codification is really prominent in Indonesia. And that is the thing that we still try hard to approach the government to make it happen. Thank you.
Thank you. Yeah, it seems like there's still quite a bit of work to do, and you point out the idea that it's not connectivity only to like see what people like farmers are doing, but also try to understand the level of engagement, understanding, and actions that different stakeholders might have as we have more people moving away from rural areas into the city. How are they engaging with their soils, and is a very important question. Thank you so much for your time. Thank you everyone that attended. This has been a really eye-opening conversation on just how much more we have to do. There's still quite a bit of work ahead of us to be able to understand how we can actually secure soils, because we're all in this spaceship, and we all got to coordinate and collaborate if we're going to be able to get keep moving ahead. Thank you to all of our speakers for your time and for putting this together, and thank you for your questions. Please do go and click on that link and give us some feedback. We hope that you join us in the other conversations as well, and we keep this conversation moving forward. Have a wonderful morning, afternoon, evening, wherever you are in the world. Thank you.
Thank you.
Thank
Thank
you.
you.
Julia,
Thank you.
Martina, and Christine. Thank you, everyone.
And I will stick around if anybody wants to. I'll stick around and see if anybody wants to have a conversation at the very end.